polynomial and synthetic division. All right, so it says the division algorithm. It's lovely. It says the divisor times the quotient plus the remainder equals the dividend. Okay, I know you guys don't remember those words from elementary school. It's fine. We're going to talk about them. So you'll often see me write P of x equals D of x times Q of x plus R of x. The of x's just mean that they can have x's in them. It's like polynomials multiplied. So it says, for example, if I divide 3,722 by 12, you end up getting 310 as our quotient, and then you get a remainder of 2. So if your remainder is 2, let me say equals 2, then you could write it out and you could say, okay, my dividend, the thing I started with, equals the thing I divided by times what was left on the top of the division plus my remainder. Okay, so that's how it's set up. And you can check and it will always work out. Sometimes I'll also use fraction form, which you guys probably learned in elementary school as well. Like for a long time you wrote remainder 2, remainder 3, remainder 5, right? And then all of a sudden you started saying, well, this is really 310 and I have 2 left out of the 12. So 2 out of 12, which would be 310 and 1/6, right? So we're going to do that as well with polynomials. Okay, so the first one. So it says divide x cubed plus 6x plus 3 by x squared minus 2x plus 2. Okay, I like to think that I'm a pretty good long division teacher. And I've seen a lot of people do this in a way that isn't the best. So what a lot of people do is they just write it out and they're like, okay, I'm going to do x cubed plus 6x plus 3 and x squared minus 2x plus 2. But the thing that gets confusing with that is when you start doing your first thing, like if I multiply through by an x, so don't write this, I get x cubed minus 2x squared plus 2x. And things aren't lining up. We don't want things to not line up. We want all of our x squareds to line up, all of our x's to line up, because it's really confusing if you're trying to combine your terms and you're combining this way, right? Isn't that confusing? So we're going to do one little thing to make our lives easier. Whenever we see between like our first term x cubed and our last number 3, if I'm missing any terms, I'm going to put in zeros. So that goes the same for the dividend and the divisor. So if I have x squared and then I skipped over an x term, I would put a 0 in there. So I'm missing an x squared term, so I'm going to put in a 0x squared. So like I was saying, if I was missing this x term, I would put in a 0x for the divisor as well. And I started out, so I'm like, okay, x cubed plus 0x squared plus 6x plus 3. And we're dividing by x squared minus 2x plus 2. So now I do just what I did with regular long division. I say, what do I multiply x squared by in order to get x cubed? So we're looking at the first terms only. So we're saying, what do I multiply by this to get that? So what do we need? X, totally. So I put an x up there. And just like with our normal division, maybe I should do this normal division off to the side. So when I put a 3 here, I take my 3 and I multiply by 12, right? And then I put it below. So I'm like, okay, 36, got it. That's what I'm going to do here. I'm going to take this x and I'm going to multiply by everything that was in the divisor. So I'm going to do x cubed minus 2x squared plus 2x. And then with our regular long division, we drew a line and we subtracted, right? That's the same thing we do here, but when we subtract out a polynomial, we want to change all of their signs and then add, right? So when I draw this line, I would say, draw the line and change the signs. Do you guys remember this? I have many cheesy catchphrases. Add straight down. So now our x cubes go away. They should. The next thing I have is 2x squared, and then I have plus 4x. What's our next step? Yeah, we're going to bring down that plus 3 because in the next line, like with the next step I do, I'm going to have 3 items lining up underneath it again. So I always drop that next term. Just like here, when I subtract the 36 and I got 1, I now drop the 2, right? It's the same process. And then we repeat. So now instead of, like in this division problem, I would say 12 goes into 12 how many times? Right? So now we're looking at these ones, and we're like, oh, it goes in 1 time. That's what we're doing over here as well. So we're saying, what do we multiply x squared by in order to get 2x squared? 2. A 2. So So we're going to get a plus 2 up here. Now when I put that 1 up here, I didn't do 31 times 12, right? I now took the 1 times 12 and wrote 12, right? Does that make sense? That's what I'm doing here as well. I'm taking the 2 and I'm multiplying by everything here. So when I do, I get 2x squared minus 4x plus 4. And then I draw the line and I change the signs. I always circle them because I often have people ask me questions in the middle of long division. They're like, Mrs. Cox, can you help me with a question? I'm like, I'm in the middle of the problem. So that way I know that I've done that. Okay, so now I add straight down. So I get 8x minus 1. Now can I go any more? Can I say, what do I multiply x squared by to get 8x? I mean, I could, technically. I could be like, oh, 1 over x times 8, right? 8 over x. That's weird. Okay, we're just going to be done there. That is now our remainder. So we're going to have a remainder of 8x minus 1. So the things we're looking for as you do this is that on the top, do you see this x plus 2? That quotient is always going to be, like if I started out with an x cubed, the next thing's going to be an x squared, an x, and then a number. So it's going to start with a power, start with a term and go all the way down. Then once we get to the number, the thing that's left is our remainder. Okay? So that's one way you can check that you did it right. So now if we're writing it in this form, p of x was our original polynomial, our dividend as we call it. D of x is what we divided by, so x squared minus 2x plus 2. Our quotient was the thing that we got on the top, the x plus 2. And we do plus our remainder, 8x minus 1. And you could check this by multiplying the x squared in, multiplying the negative 2x in, multiplying the 2x in, and combining all of your terms, and you would get exactly this. Okay, so that's why it's kind of nice to have that form, so if you have lots of time left on your test, you could always check. All right, so I want you guys to go on break really quickly. All right, so that was long division. So this one says the same thing, and it says write your answer in fraction form. So again, you're looking through at the dividend and then the divisor to look to see if you're missing any terms first. Okay, so like on the top, I'm missing an x term. On the bottom, I'm also missing an x term. It doesn't matter that they're the same thing. Some people are like, oh, well, they're both missing x, so it's still going to line up. It doesn't line up. So you got to put those in. So we're going to have x to the fourth minus 3x cubed plus 4x squared plus 0x minus 9. And we're dividing by x squared plus 0x minus 2. I don't know why I put that below. Dividing by x squared plus 0x minus 2. Let's put it there. You guys are just going with it. All right, so as I do this, I want to think about what I'm going to have on the top. So you guys did this in Algebra 2. You should be to the point where you should be able to think about these problems and be like, oh, I'm going to have something that starts out with x squared on the top. Do you guys see that? Because I have x squared multiplied by something to give me x to the fourth. So I'm going to start out with x squared, and then I'm going to have everything down from there. So it's going to be like an x squared, an x term, a number, and then I'm going to have the remainder. So we're going to go through 3 rotations of this, okay? So I'm going to take my x squared, and I'm going to say, what do I multiply x squared by in order to get x to the fourth? So I need an x squared. So I'm going to multiply through by x squared. I have x squared times x squared is x to the fourth. I'm doing all this. X squared times 0x is 0x cubed. And then x squared times negative 2 is negative 2x squared. Okay, and we want to subtract that from our previous polynomial, so we're drawing the line and we're subtracting. In other words, we change all of these signs so that we can add the opposite, right? Subtracting. So our x to the fourths go away. Our x cubes now are negative 3x cubed. And we have plus 6x squared plus 0x. And we go through the process again. So we say, what do we multiply x squared by in order to get negative 3x cubed? You guys see those? Here and here. So we need what? Negative 3x. Is that making sense with our x squared, x's, numbers? Yeah, we're good. So now we take our negative 3x and we multiply by all 3 things. So negative 3x times x squared is negative 3x cubed. Negative 3x times 0x is 0x squared. Negative 3x times negative 2 is positive 6x. We draw the line, and we change the signs. And we add straight down. So I get 6x squared minus 6x. And I drop that next term. So I get minus 9. And then I go one more time. So I say, what do I multiply x squared by in order to get 6x squared? So I need a 6. Is it still following the pattern? X squared, x, and the number? Yep, we're good. So 6 times x squared is 6x squared. 6 times 0x is 0x, and 6 times negative 2 is negative 12. Draw the line, and change the signs. So what is our remainder?
6x plus 3.
Ah, good job, guys. Usually people are like 3. They forget the x's. So our remainder is that. So previously we wrote remainder negative 6x plus 3. But this problem says to write it in fraction form. So we're going to say plus our remainder, which was negative 6x plus 3, divided by our divisor. So the thing we divided by was x squared minus 2. So we do over x squared minus 2. And that is our final solution. Okay. On a scale of 1 to 10, where are we at? Do we feel good, like 9, 10, or bad, 1, 2? Yeah.
Wait, what's with the remainder?
It's remainder divided by the divisor. So you take whatever's here and you divide by that. Just like if you had, what was the one we had, like 31, 22, and we had like a remainder of 3 or something, we would write whatever this number was, and then it's 3/7 on the end. I don't know what it is. Just making numbers up. Okay, so on a scale of 1 to 10, where are we? A 6 or 7? Okay, like as if you go home and you do your homework for a little bit, and then you're like, oh, I'm at a 9 now. Is that the whole point of homework? Maybe. Yeah, hopefully. All right, so divide. X squared minus 5x plus 4 divided by x minus 3 using synthetic division. So synthetic division, if you remember, it always starts out with this little sketch, like a backwards L and a line. Okay, and we put it's basically a shorthand. We don't put any x's in, we just put numbers. So in the backwards L, we put 3. It's the 0 of the divisor. It's what, if I set it equal to 0, it's what I would get, right? X equals 3. The reason it's the opposite of what you think, like a lot of people think it will be negative 3, is because with synthetic division, we just add straight down. But with long division, remember how we changed the signs and then added? This is taking care of all of the changing of the signs, okay? All right, so then we put our 1, negative 5, and 4 here. My calc students said they do not remember this. It made me so sad. Do you guys remember this? Good. So we drop the 1. 3 times 1 is 3. We add straight down and get negative 2. 3 times negative 2 is negative 6. We add straight down, we get negative 2. We box that part in, that's our remainder. All of these numbers represent things. So this 1, negative 2, do you guys remember what that is? X minus 2, exactly. So our final answer is x minus 2 with a remainder of negative 2. So putting it in this form, our polynomial that we started with was x squared minus 5x plus 4. We divided by x minus 3 and had a quotient of x minus 2. And our remainder, so what we add on to the end, is a negative 2. And you can check. You could FOIL that out and combine with the negative 2, and you would get x squared minus 5x plus 4. So for those of you that have trouble with, do you guys remember how to like factor? Like this is the difference of 2 cubes. If you don't remember this, like this is how it factors. X minus 3 times x squared plus 3x plus 9. Do you remember that? Okay, a lot of my calculus students, again, forget this one. They forget the SOAP formula, like same, opposite, always positive. They forget that. And I always say, well, you could always do it with synthetic division. And they're like, wait, what? So if I have x cubed minus 27 divided by x minus 3, I put 3 in the backwards L. I have 1x cubed. no x squareds, no x's, negative 27. So I have 1, 0, 0, negative 27. And I divide. So I drop my first term. 3 times 1 is 3. Add straight down, I get 3. 3 times 3 is 9. Add straight down, I get 9. 3 times 9 is 27. Add straight down, I get 0. So when I was in school, I always boxed in the remainder and then I went backwards. So I was like, okay, 9 is my number, this is my x, this is my x squared. But if you think about it, if I have an x cubed and I'm dividing by something with x, I'm going to end up with something that starts out with x squared, right? So this should be x squared plus 3x plus 9. Is that what we had up here? Yeah, it's like when we wrote it in this form, the remainder was a 0. That's what it means to factor something. It means when you divide, you don't have a remainder. Does this make sense? So we factored it. All right, so use synthetic division to factor the sum and difference of cubes. So we can do that. So if I have x cubed minus 125, do you at least know what the first parenthesis is? Like, if I was writing this as something cubed, do you guys remember what's being cubed? X minus a 5, right? So that's what we're going to divide by. We're going to find x cubed minus 125, and we're going to divide by x minus 5. So I'm going to put 5 in the backwards L. I have 1x cubed, 0x squared, 0x minus 125. Whoops. Ugh, struggling. All right, so drop the 1. And I go through my process again. I'm going to let you guys try it. Some of you guys are like looking up, looking down, looking up, looking down, looking up, looking down, and that makes me worry that you don't know how to do synthetic division. So I always drop the first term. Diagonals are multiplication. Verticals are adding, right? So we drop the first term and we had 1. We do our 5 times 1 and get 5. We add straight down, so add these, and we get 5. We now do this multiplication, and we get 25. We add straight down, and we get 25. And then we do this multiplication, and we get 125. And we add straight down, and we get 0. Did you guys all do that? Okay. So we have 1, 5, and 25. Okay, we had an x cubed term, and we were dividing by an x term, so this starts out with x squared. X squared plus 5x plus 25. So what we're saying is that this divisor over here, which is 5, what does that represent, though, as a divisor? Not just 5. X minus 5, right? So we have x minus 5. I asked a weird question. And then x squared plus 5x plus 25 is the quotient. So we have our divisor times quotient equals the original. So we factored it, right? All of this x cubed minus 125, whoops, 125, is equal to that. Make sense? So the next one, ooh, 729, anybody know that one? It's a tricky one. I don't know. If you don't know, did you guys know how to do the cube root of 729 on your calculator? So you can do, what I often will do is I'll do 729 raised to the parentheses 1/3 instead of searching for the cube root button. So what do we get? 9. All right, so we're going to take our x cubed plus 9 cubed. And we're going to say, okay, I'm going to take my x cubed plus 729 and I'm going to divide out by x plus 9. So in my backwards L, what do I put? A negative 9, right, the opposite. So I have 1x cubed, 0x squared, 0x, 729. Ooh, these numbers are going to get big. Are we ready for this? We drop the 1. Negative 9 times 1 is negative 9. Add straight down, I get negative 9. Negative 9 times negative 9 is 81. Add straight down, we get 81. Gabby, you with me? Negative 9 times 81 is, what do we think it is? I hope it's negative 729. Sometimes you can be like, oh yeah, that's totally it. All right, so we get a remainder of 0. So we've now factored into x plus 9 times x squared minus 9x plus 81. And you can check, you could multiply that all out, it works. So it equals the x cubed plus 729. Okay, still feeling good with this? All right, so let's try the next one. So go ahead and do it along with me. Active note takers, right? Strange things you hear in the hallway. All right, did you guys all get a remainder of 12? When I'm grading your tests, you know how I'm like the fastest grader ever? I pride myself in that. That's what I look for, your remainder. Because if you don't have the remainder right, you got the problem wrong. So I just go straight to the remainder. So remainder of 12. So we drop that 2. 2 times 2 is 4. Add straight down, we get 5. 2 times 5 is 10. Add straight down, we get 5. 2 times 5 is 10. Add straight down, we get 12. So what does this mean then? It means that our original function, 2x cubed plus x squared minus 5x plus 2, is equal to our divisor, which was x minus 2, times the quotient. So what's this quotient? 255? 2x squared plus 5x plus 5, right? So it equals our quotient, 2x squared plus 5x plus 5. But we still have a remainder, so we do a plus 12 on the end. All right, so it says use synthetic division to show that negative 3 over 2 is a 0, and then find the other zeros. So if it's a 0, that means it's an x-intercept, which means it factors evenly, right? It means like it's a factor, like x plus 3 over 2 would go into it evenly. So we want to show that we get a remainder of 0. So everybody always freaks out when we have fractions. They're like, oh, this is going to be so gross with fractions. It's usually not. So if you're checking a fraction to see if it works and it starts getting really gross, it's probably something wrong. Because see how negative 3 over 2 times 4, that comes out nice and even. What is that number? Negative 6, right? Negative 3 over 2 times 4, so the 2 and 4 will reduce out. So we get negative 6, and when we add straight down, we get negative 10. So what's negative 3 over 2 times negative 10? Yeah, it's 15, because we'd get 30 on top over 2, which is 15. And then negative 21 plus 15 is negative 6. So what's negative 3 over 2 times 6? Negative 18 on top over 2, so negative 9. So did it work out? Yep.
Yeah, it's a positive 18.
What did I do?
It's negative 6 times negative 3.
Wow, what did I do? I see I have a negative 9, but I want it to work out, so did I mess the sign up somewhere?
But it's negative 3 halves times negative 6.
Oh, no, I get that. I get that this is supposed to be 9, but it needs to be a 0. So that's why I just put a negative 9 there. So let's see. So I did my 4, negative 4, negative 21, and 9. So 4 times, because it's not going to be a 0. So I got to figure out where my mistake is. So negative 6. So let's make the original problem a negative 9. Because I messed something up, didn't I? My bad. All right, so if I'm finding my other zeros, that means I've factored into x plus 3 over 2 times 4x squared minus 10x minus 6. Okay, and you guys remember why, like, we don't usually see, like, x plus 3 over 2. Don't we usually have, like, 2x plus 3? Does that make sense? Yeah, so sometimes when you do this, like, you can kind of see how we have a GCF of 2 here? Like 4, negative 10, and 6. You could pull out a 2. And then you could take that 2 and kind of move it over to the other one. But it doesn't really matter in this case because I'm just finding the other zeros anyway. But see how I put the 2 in with this one? So we'll be doing that when we factor polynomials eventually. But if you don't want to do that, that's fine. So we can just write this part and then continue to factor this part. Okay, so it's a tricky factoring one. So see if you can get it. So 2x and x. So we definitely need opposite signs because we need it to multiply by -3. Any thoughts? So I think the 3 has to go with the 2 and the 1 has to go on the inside. So I need a -6 and a +1. Did some of you guys try it another way? This is like one of my favorite ones to put on a test because I never have to think about where the signs are because it will always factor. It's just tricky for students though because sometimes they're like, oh, 2x minus 3 and then x minus 1 and they're like, look, the outer and inner combines to be -5. But look at the last terms. They multiply to be +3, right? So it's a tricky one. All right, so that means we get our 3 solutions. So we definitely get the x equals -3/2 from here. You can get rid of this if you want. And then we get x equals -1/2 from there and x equals 3. So our other 2 solutions are -1/2 and 3. All right, so I taught you guys the a plus bi form on your calculator earlier. Get your calculators out. Okay, so we go to mode and we go down to a plus bi form. So you guys have already done that, so you're good. Okay, these are super annoying. I never liked these, yeah.
I don't know what happens.
Do you have a Casio? Is that what it is? Okay, grab one of mine, so you can grab this one. Anybody else need one? Okay. Here's that.
Abby McKinney took mine.
For her test the other day.
All right, so we got it in a plus bi form, and we're showing that we have a root of 3x cubed minus 1x squared plus 20x plus 50. So if we're showing something's a root, we basically want, at the very end, we want to get a 0, right? Okay, I used to have to do these by hand. They were not fun. And then I learned about the glorious a plus bi calculator button, and I was like, well, that would have made that a lot easier. So I'm going to teach you with the calculator. So I'm never going to put you through the pain that I had to go through. All right, so here we go. So the first step in synthetic division is we drop the 3, right? So we're going to do 3 times 1 minus 3i. Now that one you can probably do in your head. What's 3 multiplied by 1 minus 3i? 3 minus 9i. And then we add straight down. Can you do that one in your head? Yeah, -1 added to 3 minus 2i is 2 minus 9i. Do we agree with that? Now do you see where it gets gross? Yeah, because you would have to do 1 minus 3i multiplied by 2 minus 9i off to the side. And you have to FOIL it out, get your I squared equals -1. But I'm going to let you use your calculator. So we have 1 minus 3i. So the I is where the decimal point is. And then 2 minus 9i. So we multiply them, and we get -25 minus 15i. Do you guys all have that? So we write that up there. So -25 minus 15i. Okay, and I'm just going to kind of keep this going on my calculator. So what do I need to do? I need to add 20. That's not hard to do without a calculator, but we're going to go ahead and do it on our calculator anyway. So we get -5 minus 15i. What am I going to take that -5 minus 15i multiplied by now? The 1 minus 3i. So I would just do times, so it takes your answer, times, and then parentheses, 1 minus 3i. And when you do it, what are we hoping and praying that we get? -50, do we? Yes. So now it wants us to find the other roots. So it's like, well, how do we factor that? So we showed with synthetic division that it worked, but now it says find the other roots. Ugh. What else has to go into it? If I have 1 minus 3i as a root, what do I need, Eilish?
1 plus 3.
I need 1 plus 3i. So then you would continue with 1 plus 3i, and you would do it again. So you drop the 3, you'd have 3 plus 9i. You add straight down, you get 5. This one's not painful to do without a calculator. 5 times 1 plus 3i is 5 minus 15i, plus 15i. And when we add straight down, we get 0. It factored evenly. So we're left with 3, 5. What is 3, 5? Yeah, it's 3x plus 5. So if I set this equal to 0, I get 3x equals negative 5, x equals negative 5 over 3. So our other roots, well, let's just say our roots in general. So our roots were the original one, 1 minus 3i. The second one we found 1 plus 3i, and the negative 5 over 3. Okay, so it's not too painful with your calculator. It's a little bit painful though, right? Okay, so then this next part says, sometimes we choose our battles in math. So we'll do this next time, but I'm going to show you kind of how to do this with like long division instead of synthetic. Because if you know you have 3i, then you also have to have negative 3i. What does that mean would be a factor then? If I have, well, what would be in parentheses then as a factor? If I have 3i and negative 3i, we're kind of thinking backward. X squared plus, what would be part of our solution? X squared plus 9. Good, Greta. Does that make sense? So basically, we're going to take x squared plus 9, and we would go into our synthetic, or into our long division instead of synthetic. Okay, so we'll talk about those two next time. It's getting a little long.